again this important topic from PMI ACP. And we will also cover Kanban board, WIP limit, and if possible, if you are getting time, earned value management. So in customer value prioritization, there are 5 methods: Kano model, Moscow prioritization, monopoly, 100-point method, and Karl the relative weight method. So in PMI ACP, this is only a theories covered from all these 5 methods, like how the customer value the product backlog. So in Scrum, we have product backlog. In feature-driven development, we have feature list. In DSDM, we call prioritize feature list. So all these things are the set of requirements which customer expects the team to deliver. So in planning value, what does customer does in order to prioritize this feature list or product backlog? So the first method the team use to prioritize the backlog is called Kano model. So in exam point of view, there can be questions like they will ask you what is expected in Kano model. So these explanation you need to be aware. So in Kano model, there are actually 4 types. One is exciters or delighters. Yeah, I'll come to that. So in Kano model, there are actually 4 types of people they categorize, or they categorize customers into 4 types. One is exciters and delighters, and another is linear and threshold. So you can see that this is actually in y-axis they plot customer satisfaction, and in x-axis they plot your requirements or feature presence. It's a set of product backlog. And if you can see that this left bottom is actually your feature is absent and customer satisfaction is low. So our intention is to how we can reach at this quadrant where which is a top upper quadrant where the feature presence is fully implemented and your customer satisfaction is high. So we'll start from exciters. So exciters are the people, like if you deliver a set of features from your product backlog, then your customer become exciters. So those category comes here. And linear means that the feature from the product backlog that you deliver, it is a must to deliver. So once you deliver that feature, your customer are satisfied. So that comes under linear. And threshold is something that it is a must-have. So those features are must-have, and linear are something. So the threshold features, we say that it is for the first release, these are the mandatory requirements that you need to complete. So those are threshold, and linear is actually something once you deliver that features, it's better, but it is not mandatory. And something exciters and delighters are something like if you deliver that feature, your customer will be more happy. And there are one more that is indifferent. So which means that this is a low priority items in your product backlog which you need to eliminate. So this is what we learned in value stream mapping. Try to eliminate the features that doesn't add value to customer. So in Kano model, they comes at the center. So these are the features that doesn't add any value to the customer. So this is Kano model for customer satisfaction. Okay. Now, the very commonly used one, Moscow model. So you guys must all know this, what is Moscow model, and you can expect some questions in PMI ACP on this. So Moscow model is something like how you prioritize your product backlog. For example, if your product backlog have 20 features, so how you make sure that which is the highest priority and which is the lowest priority. So there are different methods like a monopoly, 100-point method, where you work with your client and understand that which are the features are must have. So it is called minimum usable set, and which is so this must have in Kano model, it is called threshold. So you might have seen in Kano model, this is threshold. This is actually the must-have in Moscow model. And should have is that it is not important. Those features are not critical, but it is good that if you have. And the third set is could have. These are desirable set of features that customer is expecting, but not important. And won't have is something, it is like an indifferent in Kano model. There is a central box called indifferent. So same here is won't have, which is something that as a team you need to eliminate. And there is the third concept for planning your value is called monopoly. So you might have seen the people playing this, kids playing the monopoly money. So it is actually what happens is that you create a monopoly money that is equivalent to your project budget. Say that if your project budget is $1,000, for an example, then you create this dummy money for $1,000 and you will distribute to your customer or your stakeholder, and you will analyze how they are spending their budget. For example, they have 10 features and how much fund they are allocating to each feature. So based on that, you can derive your Moscow model. So for an instance, if your stakeholder is spending $500 for a feature, which means that it is important for him. Out of 1,000, he is spending 5,000. So you categorize that into must have. And another is 100-point method. So 100-point method is a similar like monopoly, but instead of the project budget, you are given each person or each stakeholder 100 points. And you are asked them to distribute this 100 points among all the features. So some people might give 15 points to a feature and 5 points to another feature. So based on that, your team can prioritize. The highest point features, you put it as must have, and the low point features, you put it as could have or won't have. Okay, now the next is Karl relative weighing model. Maybe your bit attention is required here. But from a PMI exam perspective, this max is not required. They will never ask this max question. It's only they ask, like for a mathematical model, we use Karl. But maybe if you're going for some interviews or something, this might be useful to understand how this is worked. By seeing the chart, it seems a bit complicated, but if you can, we will take 5 minutes and walk through this. You can see the first column is the features, list of features. It says add to cart, update cart, proceed to pay, search a product, create a wish list, search by category. So this is your product backlog. And now the first step is you ask your customer to rank the benefit and penalty. So you give a random number, like it's not 100-point method. You don't give a 100 point. You say out of 10. Say that what is, if we deliver this feature, add to cart, what is the benefit you are getting? So customers say, okay, out of 10, I get a benefit of 5. And also customers say, if you don't deliver this, out of 10, there's a penalty of 2, which I might lose. So if you can see the last one, search by category. Customer says that if it is not delivered, it's a penalty of 10, which means customer value it more. Create a wish list. So these are high features for customer. So the first step is customer put a random number between 1 to 10 on benefit and penalty. Now your team will calculate the total value. So for the benefit, there is a weightage of 2 given, and for penalty, a weightage of 1 given. So from where you derive this value is based upon your team. Your team has some max or some relative estimation. They assume that, okay, for a benefit, it's a 2 weightage and penalty is 1 weightage. Now the total value is a simple max, 5 into 2 plus 2 into 1, which gives you 12. Now you put all the values here, 12. So it sums up to 103. Is everyone with me? Any clarifications required? You can raise your hand, put in chat if I want to stop and explain more. Okay. Yes, it is on a scale from 1 to 10. Yes, Chandra. Actually, it can be on any scale, but for calculation easiness, we give 1 to 10. Or you can even use 100-point method. You can even use monopoly. So let us assume if you are using monopoly means it becomes complicated. For example, your project might be $1 million, $2 million. So max become a bit complicated. So they give a relative estimate. Let's say 1 to 10. For example, add to cart is 1. Then like create a wish list might be 5. Satyajit, DSDM is Dynamic System Development Method. It's actually Agile project delivery framework. Just like Scrum, Kanban, and all, DSDM is Dynamic System Development Method. Should penalty be always be lesser number than benefit? No. For example, if you can see a search by category, for customer, the benefit of getting the search by category is 6, but penalty is 10. So which means that it is important for him. So you assume yourself as a customer, and if you have been given to given a random number from 1 to 10 for your product, then you give some random numbers like you used to rate Book My Show, Paytm apps, and all. They will ask mark between 1 to 2 your experience. So similarly, it's a simple max. There is no much calculation involved, but how this weightage is calculated is again depend on your team. So your team assumes that if we are delivering something to the customer, it is twice the value as we are not delivering something, which means that penalty, if the value of penalty is 1, the benefit is 2. Yeah, it can be on any scale. Weightage is determined by the customer, determined by the team. It is normally a random weightage they give. They assume that penalty is 1 and benefit is 2. Okay, now from there they go to total value. Total value is 5 into benefit plus 2 into 1. You can even put benefit as 1 if you wish. So it comes as 103. Now you calculate the value percent. So value percent is actually your value for the individual feature divided by total value percent. So that is 11.65%. Now you calculate all the percent. So here is the important thing. When you calculate all the percent, it comes to 100. So even though if you put here 1 or 2, the percent calculation will comes to the sum of all the percent, value percent of all the features summed up, it comes to 100. So it's just to distinguish. It's to distinguish between the features. So if you can see here the importance. For example, now from here, the team can understand, okay, I need to first work on create a wish list and search by category. There can be dependency on other features, but the first release customer is expecting create a wish list, search by category. So this should go as a must have. And you can see 18.44 and 18.44, this can be a should have, and this can be a could have, and the last one maybe won't have. So won't have is something because if you can see the variance is very less. If it's something it comes to 3%, 2%, then you can consider as, okay, then you talk with your customer and say, is this something really you want? So probably their answer will be no, because the reason is weightage is less. Or there can be a possibility they might have given a wrong estimation also. Okay. Now, if you have any questions in between, drop it in the chat. Now, that's the first phase of relative weighting model. And in the second phase, once we get the customer value percent, it's a work of now developers to estimate cost and risk. So here also, if penalty is 1, benefit is 2, then they put cost as 0.5, risk as 0.5 and cost as 1. You can also put risk as 1, then cost as 2. So here the estimate is multiple time of risk creates a cost. So developers put some random numbers saying that they assume that add to cart, it costs 2. It can be a dev lead calculating, say that 2 developers may work on 2 weeks, and he calculates the cost and he put a figure like 2, just a random 2. It doesn't have any relation. Then he says that, okay, update cart is also 2 because the work to add the cart and update that cart is now same. Now you do relative estimation and found out that search the product is twice the work of add to cart. It's only an example. And proceed to page 3, create a wish list is 2. So he says that relative cost, total he needs 15 points as cost to deliver the 6 features. Now see, he calculates cost percent. So cost percent is cost divided by some percent. Now you can see that whatever value you give here as weightage, you will get 100%. Now again you calculate and you see that such a product is giving 26.6% of the total budget to do this work, and customer is valuing it 18%. So you can do a comparison between 18.44 and 26, but you can also see here that if you are spending 13.3% of your budget, you can deliver 21.3% of the value to customer. And here is a case like if you are spending 20% of your budget, you are only delivering 40%. So probably we can keep this aside, proceed to pay. Maybe don't put it as a first priority list, because this is customer value, which is important to customer. But again, you have to look at your budget. You have to spend more money to deliver low value product. So that's the first level of initialization. Then you consider, you add into risk factor also. So your value is calculated, cost is calculated. Now you consider risk. So risk, your development team does this. So he feels that in order to do the add to cart, there is a risk factor associated. So there might be some risk factor, maybe related to payment gateways, APIs or something. And he says that it's a value of 1. You just put a base estimate as 1. Then based on that, to update the cart, there are some risks, which is twice the complexity to add to cart. So he put it as 2. So similarly, he put a relative risk to all the features. And he put it as 11 is a total. Now he calculate risk percent. Risk percent is 1 divided by same max, 11%. That gives you 9.9. Now again, your team or your scrum master or your project manager can calculate, do an analysis based on risk, cost and value, which means that in order to deliver 21% value, there is a 27% risk and 30% cost. So you can do some math your own based on your product and come to some conclusion like this is risk here, this can be avoided. So our intention is to prioritize this. So among the 6, which should go first? So you consider value, cost and risk. And based on that, you create a priority. So this is the last formula. So priority is divide the value percent, that is this 11.65 value percent, by cost percent into cost weight, that is this cost weight, plus risk percent into risk weight. So that will give you the percent priority, which means that considering value, cost and risk, you should first deliver, create a wish list. So it is advisable that keep it as top of the list because it is giving 0.95. Then you give search by category. Then you keep add to cart, then proceed to pay, then update cart, and then search a product. So this is a mathematical model. Challenges are, challenges for this model is customer might give you very random numbers which cannot be accurate, and also developers find it very tough to initially estimate what is a cost and risk. So this is evolving. So as a project progress, you can revise this because initially your developer might say add to cart is 1. Then later on the project, he might discover that it is not 1, it is 3. So you can in your product backlog grouping in Scrum, there is a product backlog grouping where you can continuously refine your product backlog based on this mathematical model. Cost can be replaced with effort. Yeah, cost or effort, but something monetary. So that's a good catch, Maya. Value for create wish list is 20. you're saying here, I put it as 21.35. It's actually 22 divided by 103. How much it comes? 22 divided by 103. It's 21. Okay. Okay, so basically this is only an example, because if you can see here, the priority here curve is actually entire upside down. You can see the highest priority is 0.79, that is search by category. Obviously that would not be the case in real scenario. So these are actually dummy features, where just to show how the smacks work. Okay. Yeah, and from the PMI ACP exam, it's not required. You don't have to, maybe you don't have to learn this formulas. It's not required at all. You can accept some questions asking that in prioritizing the features, which is a mathematical model used or statistical model used, then it is always Karl-based relative weighting. All the others are not mathematical models. It's like based on the user field, must have, Kano model, and 100 points are not mathematical models. They are all user feedback models. Okay. Now, product roadmap is a next method to plan the value. So the product roadmap it's helpful for the customers to analyze what are the milestones. For example, I give you the project by Jan, and the product roadmap will give me a figure or an idea like what will be delivered on March, what will be delivered on July, and what will be delivered on December. So he can expect that. So that's all about product roadmap. And product roadmap also says that what are the features that coming on the first quarter, second quarter. So this is how a product roadmap look like. So this marked in blue, orange, and yellows are stories. You can call it as user stories or features or the requirements. And in product roadmap, the first one is backbone. So this is important. You have to know these terms. So in product roadmap, there is an element called backbone. So you can see that the four yellow, they are the backbone of the product roadmap, which means that they are the must-have features or the essential functionality. So which should be probably released in the first release, should be go as a backbone. And the second component is walking skeleton. So once the backbone is delivered, which means that you have delivered all the required or essential functionality for your product to stood up or stand straight. Now, in order for your product to walk forward or give some value to customer, there are, here you can see there are eight stories or 8 features that you need to release in order to make sure that the product you're delivering to customer is functional. Then all the remaining things are additional features. So in a product roadmap, when you create a product roadmap, ensure that all the must-have and should-have features comes in backbone and walking skeleton. And all the remaining, like could have and won't have, should come as additional features. So you can see that the backbone, they get released in release 1. You can call it as release 1 or sprint, whatever. These features get released on your first sprint or the first cycle, and the walking skeleton will get released on the second sprint, and on the third sprint or on the third release cycle. From these features, you can pick the most valued by the customer. So you can use Kano model, Moscow, Karl-based method to understand among this blue which one you should select. So they have selected this 8. So this goes to release 3, and again based on whatever the model you are applying, you can select the next release. So this is a product roadmap. So important thing is product roadmap gives you a very high level picture to your stakeholders, saying that these are the products that will be delivered on the on a particular milestone. And important points that you need to keep these terms in memorize: backbone and walking skeleton. Backbone are something, features which is essential, and walking skeleton are features that makes your system work. And additional features are the remaining features which can be could have or won't have, or which is of less priority. So this is how your product roadmap looks like. Now a bit complicated one, risk adjusted backlog. So again, in planning value, another method is risk adjusted backlog. So you know what is a backlog is product backlog. Product backlog is a set of all the features that need to be delivered to the customer in a life cycle of a project. So let us assume that you have seven requirements or seven functionalities. So here they have already categorized based on Moscow model, saying the requirement 1, 2, 3 have must have, 4, 5, 6 are should have, and 7 is a could have. Also they are calculated. Also they have calculated return on investment for each requirement. So I think this must have, should have, and could have is prioritized based on ROI. So you can easily see that if it is must have 5,000, 4,000, 3,000, this value comes on decrease, and it could have feature is having lesser ROI. So this is called prioritized requirement list. So this list only contains requirements, and risk is not categorized. Now what they do is, your team or your development team analyze the risk for the project. So he assumes and he identifies there are 7 risks to his project. Risk 1 to risk 7, and he also calculated that what is the impact. So which means that if this risk happens, how much it cost. So when you say how much it cost, it can be a benefit or it can be a penalty also, because risk is something, a positive or negative event. Risk is not always in a negative tone. It can be a positive thing also. So here the risk impact is 9,000. The probability of occurrence of risk 2 is $8,000. And if the probability of occurrence of risk 3 happens, then the impact is $3,000 to the project. And also the probability to happen this risk is 50%. So which means that when you start your project, there is a 50% probability that this risk you might have to face this risk. Now, earned monetary value. And your monetary value is your impact into probability. So your expected monetary value is 9,000 into 50%, which means 50% of 9,000 is 4,500. Similarly, you calculate your expected monetary value. Now, once you calculate the expected monetary value, you have 4 options for the risk. If you can accept the risk, you can, which means that, okay, if the risk 1 happens, there is an impact of $4,500. Or if a risk 2 happens, I have to shed $4,000. And the second option is transfer the risk. Like your insurance policy, you are transferring your risk to a third party by paying a premium. So here, instead of paying $4,000, you can transfer the risk to the third party for a $400. And third one is avoid. Avoid risk is something that you analyze this risk and find out what is the cause of happening this risk, and you eliminate the cause. So that is avoid. And mitigate is you find a risk response strategy. So which means that if risk 4 is happening, what is the response I need to take? So you will categorize this 7 risks to accepted, transfer, avoid, or mitigate. Any doubts? Maybe you can put in chat. Or are we good? Okay. Now, so what we have done is we have ordered the requirement, we have calculated the ROI, we have identified the risk, we have identified what is the cost of the risk occurrence, if risk occurred, and what is the probability of occurrence, and we calculate expected monetary value, and we categorize risk to mitigate, avoid, transfer, and accept. So based on that, we will redefine our product backlog as a risk adjusted product backlog. Yeah. So when you say how the risk impact is determined, is it developer's feedback? It can be developer's feedback. For example, it's a simple instance is that add to cart is requirement 1 and $5,000, which means that it need to be delivered to customer on Jan end. So what happens? It is not delivered. It's simple as that. You are not delivering value to the customer of $9,000 means there is an impact of $9,000, which means that you are not getting that ROI. And there are other factors also. What happens is it's not delivered. What happens if some technical issues occurs? So based on that, everything is calculated based on ROIs. So which means that the cost of delivery and cost of not delivery. We just have a comparison. You can calculate the risk value. And it comes from experience, and it comes from your project environment, and it comes from your previous project. And all on a sudden, initially, you may not be able to calculate the risk impact. It evolves through the project. Pushparaj is saying there's a situation, if could have ROI is higher, then it could be moved to should have or must have. Pushparaj, actually, this could have, should have, and must have is for customers. Like it's not for developers. Like we are categorizing customer and we are understanding from them which features are must have for customers. So, okay. So you're saying that, okay, there can be a possibility that ROI for a must have feature should be low. It can be low also. So there is no issue on that. It doesn't always mean that all must have features have higher ROI. So that's why we say Agile. In Agile, we are focused on delivering value to customer rather than focusing on ROI. If ROI is our motive, then like all this priority will change according to ROI. Yeah, this is only a dummy values. It can be here. It can be $100 also. But normal scenarios, even whenever you calculate, all must have will have higher ROIs. So that's how it is designed. Project it always comes like that, but reverse is also possible. So by this we completed assessing value and planning value. So assessing value, it is ROI. Why I'm repeating is because so that you will also get feedback. ROI, net present value, IRR, and planning value, it is project charter, value stream mapping, customer value prioritization, product roadmap, and risk adjusted backlog. In product roadmap, you have 3 components. Maybe you can recollect yourself. It's a backbone, walking skeleton, and additional features. And customer value prioritization, you do Kano model, Moscow prioritization, 100-point method, monopoly money, and Karl relative estimation. And we just learned risk-adjusted backlog, which means that you have a feature list, you incorporate risk features into this, and maybe we didn't explore this last one. So based on this, you create a revised list with requirement 1, and you now incorporated a risk 2 here. So earlier it was requirement 2. Now you can see you removed requirement 2 and put risk 2. So which means that this requirement 2 is having ROI 4,000 and risk 2 is also having ROI 4,000. So they thought like, okay, let's remove requirement 2 and put a mitigation plan for risk 2, which is equivalent ROI. So that's how you reprioritize your backlog. And this is not a one-time activity. It continuously evolves during every sprint. Now we completed. Now we are into delivering value. So this we will cover fast because in our first module, we have to learn this in very depth. Like there is a framework called Kanban. In Kanban, we need to learn in depth about Kanban board and WIP limits. So here it's maybe we'll just have a walkthrough. So this is how your Kanban board looks like. Those who have learned about Kanban is very familiar to you. You have a to-do list and you have a analysis, development, test and done. Or you might initially forget about this urgent and policies. We will learn in chapter 1 about that. So Kanban board, maybe we can skip this very fast. Kanban board is something for a visual indicator of your project progress. So it is actually your monitoring and controlling. Moreover, it is monitoring to understand that whether whatever you have planned in your product backlog is delivered. So you call it as visual indicators, information radiators. So they are task board. Task board is Scrum board, your charts, your burn down chart, your burn up chart, parking lot diagrams. Everything comes in delivering value. So you can see this is a tool and technique for delivering value and WIP limit. So we'll come to that in chapter 1. And confirming value is again like customer value prioritization, it's repetition. So customer value prioritization, if you can recollect, it will be good. What are the 5 methods of customer value prioritization? Maybe if anyone can just unmute yourself and say this 5 methods for customer value prioritization. Anyone can volunteer yourself and explain those 5 methods for customer value prioritization? No volunteers? Okay, they are Kano model. Yeah.
Moscow, 100 method.
Monopoly.
Monopoly, yes. And the last one is statistic.
Yeah, Karl relative model.
Yeah.
So it's must, you have to revise those things. Moscow, Monopoly money, 100-point method, Karl. Okay, now we are into our last section, that is tracking and reporting value. You can expect a few questions out of this. The first one is earned value management. So maybe a little bit of attention is required here. So earned value management, you are now going to assess like how much you have done. It's in traditional project management, it's monitoring. So how you do your monitoring in agile projects? So in x-axis you have time or your sprint, and in y-axis you have cumulative cost. Okay, and this dotted line is actually, maybe you can consider here like January to December, and this is your September maybe. So we are in September, and we are going to calculate what happens in September. So this is your planned value. So planned value is something that in your project from Jan to December, you are assuming that project is 1 year. From Jan to December, what is your planned value or your planned budget? This can be, let's take it's $1,000. So your project cost is $1,000. Okay, and it is called budget at completion. Maybe note those planned value. So planned value is something that what is the budget you have planned? It is called budget at completion. BAC is budget at completion. So that is $1,000. Now in September, you have earned very less than planned. So at this point your planned would be some $700, but you can see here you might have earned only $400, but you have spent more than $750. So you got the difference between planned value, earned value, and actual cost. So planned value is actually a plan, like for each month how much you are going to spend, and your earned value is after delivering value to customer how much you have earned. So you can see that you have planned a lot, but you have earned very less from this chart. But in order to earn this cost, you have spent more than your planned. So what is the indication of this project? This is purely out of budget, right? Is everyone with me? Yeah, is earned value is a worthiness of the project. If you are always, it is calculated in terms of monetary perspective. It's always dollar value. So earned value is always dollar. Since all these are in dollar values. So this is something you say your ROI. This is what you are expecting to return, and this is something you spend to get this. So here you can see that your actual cost is much more than your earned cost. Now what you do in order to get your project back on track. So you see that initially your budgeted completion was $1,000. Now you estimated and found out that with $1,000 this is not going to work. So that is called EAC. I believe someone is drawn. Okay. Okay. Now what is EAC? Is estimate at completion. Put it here. EAC is estimate at completion, which means that your BAC value was $1,000, but you overrun the budget. Now you need extra budget in order to complete your project. So EAC minus BAC will be your extra burden, which might requires approval from your management. So if customer is asking for more value, it doesn't add any value to your functioning organization because you are now overrun the budget and you need more budget. So there is a concept called reserves, management reserve. So there is something they have already put a reserve. They know that if management gives project manager $1,000, he will definitely overrun. So they might have get some reserve. So they can allocate this money from reserve, or they can allocate this money by asking a CR to customer, change request in terms of cost. They can say that we are over on the budget and we need more money. So this is some uncertainty happened, or customer requirement is not clear, where we might need to do a lot of rework and the actual cost shoot up. Now we need extra budget. So this is a concept of earned value management. Now we have some mathematical formula. How we analyze that is the project is ahead the schedule, behind the schedule, or it is a cost overshoot, or you are under the budget. Okay, is this concept clear to everyone? I just give some yes. Okay, perfect. So your budget is completion is your total budget. Now let's assume a small scenario where you're building 5 walls and cost for building each wall is but $1, and building each wall will take 1 day and cost is $1 per wall. So your budget is completion is $5. As simple as that. Okay. Now the planned value is something at a given point of time. What is the value of work that you can deliver? So maybe someone can answer this. On third day, what is the value of work, or what is the planned value on day 3? Yeah, Chandru is saying $3. Yes, it's as simple as that. It is actually, you have completed 3 walls, which means that 60% of the work you have done. So 5 into 60% of 5 is $3. So that's your planned work. Now earned value is like, when you've done a planned value, you are actually executing something, you are delivering some features to your customer. By delivering features to customer, you earned something. Now the scenario is, on day 3, due to rain, no work happened. So what is your earned value? Your planned value still remains $3, but on the third day, due to rain, no work happened. So what is your earned value? Okay, Mayur is saying $2. That's exactly correct, because you have only worked for 2 days, which means that you have only delivered, you have only completed building 2 walls. So your earned value is $2, but still your planned value is 3. Okay. Now actual cost. Actual cost is the expenditure or the labor cost or the expenditure that your organization incur to deliver this earned value. So which means your operational cost or your expenditure. So you can say that a building wall on day 1 cost you $1, but building wall on day 2 cost you $1.3. So how come this 1.3 comes? There can be some issues happened, some defects, some rework, or some demolishing happens. So which cost you? So what you planned was $1, but you were forced to spend 1.3. So your actual cost is $2.3. Okay. Now next is schedule performance index. So you can see here, like your budgeted completion is $5, which means your budget, and your planning is as per plan, it's $3. It's from the previous example, and you have earned $2 because on the third day, due to rain, no work is done, so no earnings. And actual cost is actually you spend $1 on day 1 and $1.3 on day 2. So this is a max. Now we are calculating something, some derivations out of these 4 figures. The first one is schedule performance index, which means that how is your schedule performing? So the formula is schedule performance index is earned value divided by planned value. So you can see that 2 by 3 is equal to 0.67, which means that you have completed 67% of the work planned. So that is schedule performance index. Now from PMI exam, this is important. If your schedule performance index value is less than 1, which means that you have done less work than planned. Or if your schedule performance index is greater than 1, which means that you have completed more work than planned. And if your schedule performance index is 1, which means that you are on track. Whatever you have planned, you have done. So similar to schedule performance index, you have cost performance index. So cost performance index also same calculation. If it is less than 1, which means that you have utilized more budget and over on the budget. And if it is greater than 1, which means that you have utilized less budget, very rare chance. And if your CPI is 1, which means that whatever you have planned so far, you have utilized. So the formula for cost performance index is earned value divided by actual cost. So you can see here, like it is 2 divided by 2.3, which gives you 0.87. So this means that for every $1 spent, the project is producing only 87 cents of work, or you can say that for every, it's actually a percentile calculation. So which means that you have to work, there is a loss of 13 cents. So there comes your estimated completion, how much work you have to more do next day in order to compensate this. So these are the few questions that you can expect in PMI ACP, not mathematical questions, but you can expect, yes, that can be. But theoretically, you need to be very familiarized. Okay, next is cost variance. So you calculated cost performance index. Now you have cost variance. So cost performance index and schedule performance index will give you percent value, how much you are varying. And cost variance and schedule variance will give you dollar value. Just like you can recollect what is the difference between net present value and internal rate of return. Net present value gives you the magnitude, dollar value, whereas internal rate of return will gives you the percent, how much percentage is different. Similarly, cost variance will gives you the magnitude, which means the dollar value, how much money we are lost, whereas in cost performance index it gives you the percentile, like how much in percent or how much with compared to $1 we are varying. So the formula for cost variance is earned value minus actual cost. So which means that your earned value is 2, it's simple max 2, and you have spent 2.3, which means that you have overused $0.3. Okay. So if cost variance is positive, which means that you are under budget, and if cost variance is negative, which means you are over budget, and if cost variance is 0, then it means that you are on budget. So if in this case here the earned value is 2, actual cost is 2, then it would have given you 0, which means that you are on budget. Now schedule variance, same set of formulas, same logic. Schedule variance, but is in cost variance they take a difference of earned value and actual cost. But in schedule, they are taking the difference of earned value and planned value. Maybe if you can recollect the first graph, you know how it comes. So here it says that earned value is 2, planned value is 3, which means that you are behind schedule by $1 worth of work. So next day you may have to do that extra work in order to keep in track. So if your schedule variance is positive, that means that you are ahead the schedule. Same concept. If it is positive, under budget, here it is ahead the schedule. So both are positive terms. And if it is cost variance is negative, means you are using more money and you are behind the schedule. If it is 0 means you are on budget, on schedule. Okay, this is one of the PMI ACP question, as well as in a PMP question. Maybe you guys can give some answer. As part of project stage review, we are presenting project performance report to the stakeholder. The report show both cost and schedule variance are positive. What does that mean? Yeah, I only got an answer from Mayur. That's correct. Answer is C. So your cost variance formula is earned value minus actual cost, and the positive means the project is under budget and ahead of schedule. Excellent. So here your cost variance is $500. Here, this type of questions you can also expect. So calculation is very simple. You need to know the formulas. If you know the formulas, you can substitute. You can derive based on the 3 things. What happens if your positive value, negative value, or if it is 0. So I have some similar set of questions. So I think we are just reached 10 o'clock now. Guys, so we just completed with, yeah, 3 questions. Okay, we'll start with cumulative flow diagram tomorrow. So any questions you have, or are you all good?